Hi everyone. Today I'm going to discuss what geoprocessing is and some of the more common geoprocessing tools, some of which you've already been using. So geoprocessing is a framework and it's a set of tools for processing geographic and related data. So the comprehensive suite. Ah. Hi all. Today I'm going to be discussing what geoprocessing is and some of the more common geoprocessing tools, some of which you've already been using in the course. So geoprocessing is a framework and a set of tools for processing geographic and related data. So the comprehensive suite of geoprocessing tools can be used to perform spatial analysis or manage GIS data in this automated way. So a typical geoprocessing tool performs an operation on a data set, such as a feature class or a raster or a table, and creates a resulting output data set. And that's the key. You're creating a new output, a new data set. So in this lecture, I'll be showing you some of the more of the built-in tools, as noted kind of with the hammer. So the built-in tools are some of the more common geoprocessing tools, but we also have to work with model tools from Model Builder. So some of the more commonly used geoprocessing tools are buffer, clip, intersect, union, append, merge, and dissolve. And these are the built-in tools. So also in the class, you'll be using a model tool, which is a model to do some kind of spatial analysis where you'll build a model to do a clip, a merge, and then you'll have some end result. And that's an automated process. Another type of geoprocessing tool is a script tool. And these you can just do similar as a built-in tool. You can also do a script where you can actually write a Python script, bring it into the geoprocessing framework, and you can run that script. So if you have a very specific task that you do all the time at your job, you don't want to have to use a bunch of different tools, you can build a script to run that. So I mentioned that geoprocessing tools are used for spatial analysis. So what is spatial analysis? And spatial analysis is the process of examining the locations, attributes, and relationships of features in the spatial data through overlay and other analytical techniques in order to address a question or gain useful knowledge. So spatial analysis extracts or creates new information from spatial data, and that's kind of the key. It's creating new information. So spatial analysis skills have many uses ranging from emergency management and other city services, business location and retail analysis, transportation modeling, crime and disease mapping, and natural resources. Whereas geoprocessing is a GIS operation used to manipulate GIS data. So in typical geoprocessing operation, takes an input data set, as I mentioned earlier, and performs an operation on that data and returns the result of an operation as an output data set. So that's kind of the key. Again, geoprocessing creates a new output data set. So in GIS, these two terms, geoprocessing and spatial analysis, are often used interchangeably. However, these two terms, while related to one another, are distinctly different. So now is how do you access this geoprocessing pane? So if it's not already open on the left of your screen, you can go up to the top ribbon and click Analysis, click Tools, and that'll open up the geoprocessing pane. And it's usually kept along with the catalog, which is usually there. I was doing some other work, so you have the symbology pane open as well. So once you open it, you'll see the geoprocessing pane. And in the easiest way to find a tool that you want to use is in the search. And so here I just typed in buffer, and you notice that you have the hammers, which is the built tools. We also have a script tool here. So put on my pointer here. So we have the hammer, we have the script, and in this one we want to generally use, we're not doing 3D analysis, we want to use the analysis tools. So here's an example, and this is for the Treasure Valley. These are fast food restaurant locations, and I would like to create a buffer. So I open up the geoprocessing tool, type in buffer, and what do I want to buffer? The input feature, which is the food restaurants, the fast food restaurants in Treasure Valley. It's going to create a new, which is important here, output feature class called fast food restaurants 1 kilometer, because I am going to buffer around each one of these fast food restaurants a 1 kilometer buffer. And under here, you notice, we'll get to it, but dissolve type, there's none. So the resulting output is a bunch of circular buffers of 1 kilometer around each one of these restaurants. Lots of restaurants closely overlap. Probably easiest to see here with this one. This is just a 1 kilometer buffer around that. Again, with geoprocessing tool, created a new output. Now I can run this and do it as the same thing, but this time I wanted to dissolve it. So I dissolve the boundaries between each of these 1 kilometer buffers, and then I just get a bigger area. So that's using the dissolve function down here, where I did not use that the last time. Again, I created a one brand new output feature class called fast food restaurants 1 kilometer, and then I just put this for dissolved. So here I have my fast food restaurant locations, the 1 kilometer dissolved buffer, and a choropleth map of the number of people who rent by block group. So I now want to find the percent of renters by block group that live within 1 kilometer of a fast food restaurant. And this is where I'm going to be doing an intersect. So here I have my fast food restaurant locations, 1 kilometer, and their dissolved buffer with the choropleth map of the number of people who rented by block group. So I have this. It's created a new output, fast food restaurant kilometers, and I use the restaurants, 1 kilometer, and the block. And now I want to find out the fast food. So here is the percent of renters, and I normalized this. Here's the renters, which was just the number, and I normalized it by the population in 2017 and of the 1 kilometer. So now we can see where the fast food restaurants are, the buffers, and the number of renters. So the lighter the color, the fewer the renters, the darker the color, the more of the renters. So that was a buffer with an intersect. I intersected, it was an intersection between the buffers and the number of renter choropleth map. So here I have a road layer, but instead of just creating a buffer around each road at a set distance, like the last buffer we did was 1 kilometer, so instead of having a set distance, I would like to vary the buffer distance based on the posted speed limit. So for roads, for example, that have slower posted speeds, I'll have a smaller buffer radius, while roads with a faster posted speed will have a wider radius. And here is the attribute table for these streets. And I can do this because it has the speed limit data in here. If it did not have that speed limit data in here, I could not do that. Maybe it would be another table that I would have to join to this or something like that. But in order to do this kind of buffering, you need this data in the roads layer. And so in this map, I perform the buffer based on streets using the speed limit. And you'll notice that the buffer size, the width of it, is smaller for residential areas, for example, these little roads in here, than they are for these more, the buffer's wider for these streets where the speed limit is higher. And here on the freeway, it's a little higher. So that's a nice way to kind of vary your buffering size based on data in the attribute table. Again, I used a dissolve, or else there would be just a bunch of buffers that would be kind of overlapping at these little intersections. And so I wanted to dissolve that. Again, the input feature was the streets. The buffer of the streets was the output feature class name. distance, I used field, speed limit, and left the rest the same, and then just made sure it was dissolved. So one of the more basic questions asked of a GIS is what's on top of what? For example, what land use is on top of what type of soil? What parcels are within a 100-year floodplain? And within is just another way of saying on top of. And what roads are within what counties, or what roads are on top of that county? Same thing. So an overlay operation is much more than simply a merging of line work. So all the attributes of the features taking part in the overlay will be carried through. So they will be added to this new attribute table of this layer. So here we're going to do an overlay and intersect. In terms of Boolean operations, it's an AND operation. So intersection computes the geometric intersection of all input features. Only those features that share a common geography are preserved in the output layer, and any polygon or portion of a polygon that falls outside of the common area is discarded from the output layer. And the new polygon layer can possess the attribute data of the features in the input layers. So it'll have all the attributes of both layers that the overlay intersect took part in. So let's look at an example here. So a city hydrologist needs to know what wells intersect the watersheds in Austin, Texas, and wants the watershed data attached to each intersecting well. So the red dots are the well locations, and the gray boundaries, polygon, are the watersheds. So here I opened up the geoprocessing tool. I typed in intersect, have this. So I want the wells that are intersecting with the watershed. Again, this is a geoprocessing, so it is creating a new output feature class, and I called it intersect watershed. And it's going to attributes to join. It's going to join all the attributes from both the wells and the watershed. So here is my new layer that was created of just the wells that intersect the watersheds. And this is I just clicked on one of the wells to open up the attribute table, the pop-up, and I divided it into two because there's so many attributes I couldn't show you all of them in one file, but they are all together. But you'll notice that here is the wells. For example, it says the well number, but also within the same attribute table, we now have the name of the watershed. So we have both watershed data and well data all contained within this one new feature data set that we did. So the next operation of an overlay is a union, and it's an OR. So a union combines the features of input polygon layer. All polygons from the input layer are included in the output polygon layer. It can also possess the combined attribute data for the input polygons and the output polygons. So here we have one layer in gray, for example, and another in yellow layer. So an OR wants both of those. And so here is the output layer, has all the data. And so here's another way to look at a union. We have a circle plus this rectangle. They lay over top of each other in ArcPro. Creates a new feature class that has both of the circle and the rectangle. And here's the attribute table. So we have both polygons, but what you'll notice here, we have a new one where the FID is 0. And the 0 is added for the ID for where the two end pieces of the rectangle do not share a common geometry with the circle. So 0 is placed there for the ID. So here in this, for example, would be the 0. The next geoprocessing tool here is a clip. And here I have Ada and Canyon County as one feature class, and Idaho Streams as another feature class. And I'd like to only work with streams within these two counties. So I'll clip the streams to the county boundaries. So again, using the geoprocessing tool, I would just type in clip into the search. It would open up the clip. And the input stream is the input is the streams. And the feature that's going to clip the streams to make the new area of just streams is the Ada Canyon County. Again, notice that we're making a new output feature class, and I called it streams clip. And now I have stream layers for just streams in Ada and Canyon County. And it contains all the attributes for the streams that are there. And so now we have just the streams. So if you work for Ada and Canyon County doing some kind of GIS analysis, you don't need all the streams in Idaho. That just is cumbersome, takes too long to draw. You just want to focus and only have the data for the area that you're interested in. The next geoprocessing tool is something called Dissolve. And here I have a polygon of Idaho counties. And I would like to dissolve the county, so I have one polygon that represents the state of Idaho boundary. So in this example, I decided to dissolve the counties based on the 2005 population, since I have this variable in the attribute table. And so here what I did was the dissolve input feature is Idaho counties. The output features, making a new feature class, Idaho counties 1, and it's just called it dissolve. And what I decided to do is dissolve based on the field population 2005, and it's going to sum those up. It creates the output of this polygon of just the shape of the Idaho state, doesn't have any of the counties, and it created just one row, because this is just one shape, and it has the sum of the population. It also has the shape length and the area within there. So I could have chosen not to include any statistics, could have not had this field, and I could have just dissolved it without that. And what it would have done was it would have created the same exact thing. The only thing it would have done differently is we would not have had this row here of population data. So you can do it either way. The next geoprocessing tool is merge. And here I have Canyon County in pink and Ada County in red, and they are two separate layers. You can notice that they're two separate layers here in the content pane. We can see that they're two separate. However, for this analysis, I would like to have these two counties be one layer, which will make working with the data much easier. To do this, I'm going to merge the two layers into a new layer. So here, Geoprocessing Pane, type in merge. I'm going to merge the data sets. Which ones? Ada County, Canyon County. The new output data set is going to be called Ada Canyon County. And I just leave this as just the defaults. I run that, and now you'll see I have just one shape file, or excuse me, or feature class, generally the same thing. Feature class, and you'll notice that each one has its own row because there's Ada County, and the other one for Canyon County. So now I have one feature class that I can work with. So append is where you're going to append one or more attribute or data sets into an existing data set. So features must be of the same type. So when you're doing append, you have to append a polygon to a polygon, point to point, line to line. And the output data set may overlap one another or the target data set. So here, the City of Austin Public Works needs a single data set that has all the street line files for its EMS. So in this thing, we're going to append these two data sets together. You'll notice the differences. There's one, arterial streets are in the light gray, and the streets are in a darker kind of reddish color. And so the key here to notice that is append is different than a merge. As a merge, append is going to append one of the layers to the other layer, where a merge just merged them and created a new data set. So here I am going to append the artery streets and these streets together. And notice we have a target data set. So it is going to append the artery streets to this street here data set. So it's not creating a brand new feature data set. It's just appending the arteries to the streets. And so here we have now one street layer with all the records and field items. So here we can show the attribute table. It's called streets. And now they have all the streets, whether they were streets or the arteries. So that concludes kind of a general overview of some of the more commonly geoprocessing tools.